All right, so we're going to pick back up where we left off last time. And the basic idea that we had been talking about is, so far in Chapter 2, the perspective that we had been looking at trig from was taking an angle or an ordered pair somewhere in space and finding the trig functions based on that ordered pair or that angle. And what we're doing now is we're taking a trig value and we're finding the angle that would have been associated with it. Is everybody remembering that? So I suspect most of you haven't started doing homework yet, which is fine, but that's kind of where we left off last time. And we had done only one example, and the example we had done was this one, number 1 on the board. So we were given we were supposed to find the inverse cosine. That was weird, wasn't it? The inverse cosine of 1/2, and what we did is we changed it into what the expression would look like with the angle theta in there. And so that's what we're going to pick up on today as well. So we have a similar example, and one of the things, let me remind you where we did something else one thing last time too, is we had talked about 3 trig functions. We had talked about sine, cosine, and tangent, and we talked about the fact that when we defined inverses, we only defined them in certain areas of the graph. And we looked at them from the graph itself, but we also should think about and talk about them from the perspective of, again, the unit circle. So cosine was the one that's sort of friendly, because when we're looking at cosine, we looked from 0 to pi. So it's the top half of the unit circle. So when you're thinking about your unit circle for cosine, you're thinking about the top half. So you're finding an angle within quadrants 1 and 2. All right? When you're looking at sine and tangent goes from negative pi over 2 to pi over 2. So it's the right-hand side of your unit circle. And your angle measures can be negative, and in fact they will be, because they have to be angle measures between negative pi over 2 and positive pi over 2. And that's where we are actually on this one. So on this one we end up with a sine value that we're supposed to be letting, let me get that red back up, equal to theta, doing just the same thing we did as last time. And this is equivalent to writing this then as sine of theta equals negative square root 2 over 2. Okay, you guys remember that? We're just changing the way that it's written to be a way that we are more comfortable with at this point. And because this sine value is negative, which quadrant am I going to be looking in? 4, right? So you want to be thinking or using a note card or something to look back at that unit circle that you memorized, and most of you did memorize it, but that's what you want to be thinking about. You want to be thinking about in quadrant 4, where do I get a sine value that's negative square root 2 over 2? Yeah, and it's at the pi over 4 angle that's down here, right? So when we learned the unit circle, we learned it sort of as all the positive angles, yeah? But we can also go backwards and do the negative angles for it, which is actually a little bit friendlier, actually, because then it mirrors the top half, right? Or the top quarter, I guess. So when we go backwards of the bottom quarter over here, it's the pi over 4 angle, and it actually would be negative pi over 4. All right, so your unit circle, this would be the negative pi over 4 angle. So this theta is negative, and make sure your negatives are very obvious. I don't want to be trying to decide if it's negative or not, but this is negative pi over 4 as your angle measure. Okay, does that make sense to everyone? All right, now some of the time you're going to be given an angle that isn't on your unit circle. And you might have directions that look something like this. Find the place value, or find the value rather, of the expression rounded to 2 decimal places. So in that case, the first thing you need to make sure of is that in your calculator you're in radian mode. Okay? So grab your calculator, and whatever calculator you're using, make sure the mode is in radian. And then most of you have the same one that I do. If you don't, that's fine. But most of your calculators have function keys for sine, cosine, and tangent, right? And then if you notice, on this particular one anyway, right above it in a different color, it says sine with a little -1, cosine with a -1, and tangent with a -1. And that's what we're doing right now. So if you select the second button and the tangent button, or the second button and the sine button, or the second button and the cosine button, that gets you the little value that's above there in a different color. So mine says second tangent, and I get tangent -1. Okay? And then I can just put in the -3 that this particular problem is asking for and hit enter. And this particular question asks me around to 2 decimal places. And my calculator is telling me on this one that ends up being negative 1.25. Did anybody else's calculator say something different? Because if it does, we need to take a look at it right now. Okay, everybody says negative 1.25. Now, the 1.25 we don't want to talk about so much, but we do want to talk about the fact that it's negative and make sure that makes sense. This is actually, again, if I were to write this in the other form that we've been looking at, this would say tangent of theta equals negative 3, right? And a negative tangent value should be just like with the negative sine value down here in quadrant 4, right? We're looking at the right half of the graph, so down here in quadrant 4. So if I'm looking for an angle value, it should in fact be a negative down here in quadrant 4, right? Okay. That's specific to tangent, right? If I were doing this for cosine, that wouldn't be true. Because cosine's the top half of the circle. I don't have any negative angles up in the top half. So this is very specific to tangent. It isn't just that a negative turns into a negative. That's not what's happening. It's because of the quadrant we're in. Okay? All right. We can also take a look at composite functions. So this is written out. I don't know what happened. It doesn't have all the details on the bottom. Maybe I forgot to finish them up, so I'll finish them up. But all this is typed out on your paper. And these are details of how to compose a function with its inverse. All right, now I think I'm complete. And so the idea is when you learned sort of like addition and subtraction, you know that they're opposite operations for each other. We call them inverse operations. You learn multiplication and division. They're inverse operations for each other. In fact, oftentimes when children are taught multiplication and division, that's sort of how they're taught division. They're sort of looking at 6 divided by 2, and the teacher asks them something like, well, what times 2 is 6? And the answer is 3, right? So you look at finding out what division is in terms of multiplication. Well, sine and inverse sine, tangent and inverse tangent, cosine and inverse cosine, they are inverse operations very much the same way. The issue that they have is they have some restrictions upon things. So if you take a look, sure enough on the first line, sine, inverse, and sine end up canceling each other out. That's sort of the idea of what you're thinking. But that only happens when the x value is between negative pi halves and pi halves. And the reason of that restriction is because the inverse sine is restricted to having those particular values. So when it doesn't, we don't have this relationship. They don't just cancel one another out. So you have to be careful with what you're looking at of whether or not you're actually in the situation that it says you could be in. So let me take a look with you on some examples of these so you can see what I mean. So the first example, I don't know what's happening here. I have a hard time believing that I didn't actually put this on before class. So let me put it on now. Is the inverse cosine of cosine of 4 pi over 5. All right. So this is the second case, right? Down here, we're in cosine. And it has, did you just see it disappear? Okay, just checking. I'm not the only one that saw it disappear. We're going to try it one more time. Okay. Oh, now that's fun. Wonder. I don't know. All right. I think I've got an extra slide in there. What's going on? All right. So what I was looking to look at is that I've got the inverse cosine first, right? So if I'm looking at this on the cosine right here, this is the first line right here that I'm on. So this is actually going to be canceling one another out as long as the angle that or the x value that I'm looking at right here, which is an angle, is between 0 and pi. So this particular problem, I don't know what's happening on my screen. We're going to try it again. Is 4 pi over 5. And at 4 pi over 5, is that between 0 and pi?
Yes.
Yes. So it fits the restriction criteria that I was described on that line, right? It fits in with the categorical data, with that information. So in fact, this will end up being simply 4 pi over 5 because it fits the restriction. Now, if it doesn't fit the restriction, we've got other issues, and we're going to encounter one of those now. I don't know what weird stuff's happening, but we're just going to fix it as we go. So this was 4 pi over 5 here, right? Okay. So I'm going to avoid trying to go back and forth because that seems to be causing I've had problems today. I don't know why. But you can look back up on your page before, right? Okay. So this is sine, which is the first box that you have. Okay. Is it the first one or the second one in terms of sine?
First one.
It's the first one because it has the inverse sign outside of it. We've got an angle of 4 pi over 5. But what is the restriction for sine? Negative pi over 2 to pi over 2. And is 4 pi over 5 within that restriction range? No. It is bigger than 4 pi. It is big. 4 pi over 5 is bigger than pi over 2. Yeah? So this is the problem. We can't just cancel out the sine inverse sine and say that this is 4 pi over 5. In fact, it won't be. So what do we do instead? Well, what we do instead is we actually look at where we are. So where is 4 pi over 5? What quadrant is it in? It is in quadrant 2. And I will draw it right here in quadrant 2. I don't know that that's exactly where it is. In fact, I'm sure it's probably not because I'm just sort of putting it in there. Okay? It's at 4 pi over 5. So this angle right here is 4 pi over 5. And that's exactly the problem. With sine, I'm supposed to be in quadrants 1 and 4, and this is in quadrant 2. So I do know, however, that in quadrant 2, I have a sine value that's negative, don't I? No, that's not right. No, I have a sine value that's positive. Excuse me. All right, so what I want to do is I want to find the sine value of 4 pi over 5 that is also positive. So where is sine positive? So let me make the note that I just said that right here. This sine value is positive here. That's terrible notation. I should do so much better. Let's try that again. Sine value is positive in quadrant 2. Where else is the sine value positive? In quadrant 1. So what I want to do is I want to draw in, inside of quadrant 1, we'll go with green. Inside of quadrant 1, I want to draw in the location where I would have the sine value that would be the same. So remember, if you're dealing with the unit circle, the sine value is simply the y value. It has to be the height, right? How high up you are. So I actually would have this same value. So we'll imagine we'll stop right here, sort of kind of an idea. Right? This value right here instead. Okay? So I'm going to take my picture and I'm going to find the sine value in the quadrant 1 or 4 that would match up with this sine value. Okay? How do I find that? Well, I find that based on reference angles. You guys thought that we didn't learn that for anything in particular importance, right? So the reference angle actually is the angle to the nearest x-axis. So what is the reference angle on the left-hand side over here in quadrant 2? What is that reference angle going to be? It is pi over 5. And how did you get pi over 5?
Because 5 pi over 5 is pi, and you subtract 4 pi.
Right. If we went from the positive x-axis to the negative x-axis, I would have gone pi. Yeah? That's a whole pi. But I actually need to come back up to get to 4 pi over 5. In other words, what's missing? Well, I'm missing a pi over 5 to get all the way over here to the positive x or the negative x-axis, right? That's the piece that's missing. Well, if that piece is missing from the left-hand side, then I can mirror this image over into the quadrant 1, and that's the reference angle that we would be talking about in quadrant 1. Okay? And I'm going to let you check your calculators to see that I'm not sort of making things up here in a minute. This angle also then would be pi over 5. Okay, so I didn't try this before I came to class, so we're going to make sure that I'm not making things up. Take your calculator. Make sure you're in radians, which you should be because we were just a minute ago. I want you to find the sine of 4 pi over 5 and hit enter. And then I want you to find the sine of pi over 5 and hit enter. And if you hold your head just right, it should be the same thing. Is it? It is, right? So you can verify that you did right. You did it right. That you worked it correctly by checking to make sure that you found the correct angle that gave you the same sine value. And it did, right? This is actually pi over 5. So I can actually change this to say inverse sine of the sine of pi over 5. Because the sine of 4 pi over 5 and the sine of and the sine of pi over 5 are equal. That's why we went through all of that work with the picture. these two are equal to each other. And you checked it with the calculator just a moment ago to make sure that I was not making things up, right? And it worked. But that's really good, because now I'm in quadrant 1, and I fit in with the restrictions that I was given, quadrant 1, quadrant 4. Now, sine and inverse sine do, quote unquote, cancel out, right? Because I'm within the restriction range that I'm supposed to be, which means that what is the solution to this? It is pi over 5. It's much more work when they're not in the restriction range that they're supposed to be, right? Because when they are, you don't really have to do anything. Okay, so we're going to think about another one now, right? Oh, really? Okay, we're just going to go with it. I'm going to write down what we have because I don't know what my iPad is doing, but it's certainly not cooperating with me. So, all right. We have the tangent. This is number 6. Number 6 is the tangent of the inverse tangent of 4. Okay, again, I'm going to avoid going backwards because this doesn't seem to be cooperating real well today. So if you take a look, we're in tangent block now, and so I have tangent listed first, which means I'm in the second line of tangent block, right? All right. So the restriction over here is that the x value is between negative infinity and infinity. That's friendly, isn't it? That's sort of like means everything. So 4? Yeah, that's fine, isn't it? Sure, no problem. Which means that my answer is 4. Isn't tangent fun? He's so nice. But would you imagine for a moment that things are not going to work so well on the next one? This is sine of the inverse sine of 4. So I'm in the sine block, and I'm on the second line. And what does it say? From negative 1 to 1. Now, you should sort of imagine as well that that's what sine does, right? Sine goes up and down between negative 1 and positive 1. It bounces back and forth. Okay? So when I'm told inverse sine of 4 in the middle, that's a problem. Because sine never equals 4, does it? Not a regular y equals sine x graph. It never hits 4. It never goes beyond 1. So I sort of alluded to the fact that this would be a problem. And it is a problem, but it's an easy to fix one. The answer is no solution. It's a pretty easy fix, right? It's not near as bad as number 5, where we actually had to twitch the codgents around and all that stuff. So this is actually not defined. So, and part of the direction says, if there is no value, say it is not defined. And it is not defined, and we need to say why. So this is not defined. And the reason is because imagine rewriting this piece right here. If I were to try rewriting this piece, this would be equal to theta. And I would say sine of theta equals 4. And I would very quickly say, that can't happen, right? Sine of theta can't be 4. So the reason that this is happening is because sine values are between negative 1 and 1. And of course, 4 is not. Does that make sense? Solutions of no solution are often scary to write down. Seems too easy. But they do happen, and that's okay. And this is one of them. I don't know. And now it disappeared. All right, we're just going to keep going. If I have to re-record this, that's just what's going to happen. All right, finding inverses. So I'm not going to write this since you have it written down on your sheet. Hopefully you've printed this sheet off. You should have. We're actually going to talk about finding inverses. And finding inverses in trig is just like finding inverses in algebra. So you've done this before. To find an inverse, what you do is you rewrite f of x as x. I'm sorry, f of x as y. Number 2, you switch x and y. Number 3, you solve for y. And then number 4, you rewrite y as f inverse x. Okay, so these are the steps for finding an inverse. And we're going to find an inverse. and state some restrictions and whatnot on one example, number 8. All right, so the example is f of x equals 3 sine of 2x plus 2. And we're actually going to do the restriction part first, okay? So the restriction part has to do with the period of the function or the phase of the function. It had to do with me finding a value that was either in quadrants 1 and 2 or 1 and 4. Which one's sine? Is sine between 1 and 2 or 1 and 4? Sine is 1 and 4. Okay, sine is in 1 and 4. Sine has the restriction that it's negative pi over 2 to pi over 2. And these are less than or equal to's for sine. And what goes between them is actually your angle. How quickly or how slow the period is affected by the angle, and this angle is 2x. So I get to find my new restriction based on using my old restriction information, negative pi over 2 to pi over 2, and the angle in this particular problem. Okay? So this angle is 2x, and I need to solve it then for x. So how do I get rid of the 2 in the middle? We've done things like this before. I divide by 2, or I could multiply by 1/2. So just because I'm already dealing with fractions, I'm going to go with the multiply by 1/2 business. All right, so I get negative pi over 4 on the left is less than or equal to x in the middle is less than or equal to pi over 4 on the right. This is my restriction. Okay? So this is how I find my restriction. I haven't actually found my inverse yet, but I found the restriction for the inverse. So this will be the restriction for f inverse of x. Okay, and let's look at one other feature of this, that is the range. What is the range of this particular function? Well, you know that sine normally goes from -1 to 1, right? Bounces back and forth. It doesn't on this function of sine, though, because it's got some other features going on. So thinking in terms of the graph, what features would affect it going from -1 to 1? The amplitude, that's one of them, and the vertical shift, right? So we're going to picture in our minds, or you can sketch it on your sheet if you'd like to, okay, the actual graph of what's happening. I'm taking my graph, and the first thing I would do if I were actually graphing this is I would do the shift, and this is going to be a shift up 2, right? Mm-hmm. So the shift up 2 means that I'm not going between -1 and 1 anymore. What am I going between?
5.
Not with the amplitude yet. Just the shift. Between 1 and 3, right? -1 moves up to 1, and 1 moves up to 3. Can you picture it? You took the graph and you shifted it up 2, now between 1 and 3. Okay. Now we're going to do the amplitude. The amplitude stretches it out of shape, right? So instead of it going from where we would have been at 2 down to 1, it's going to go from 2 down to -1, because it's got to go down 3. That's the amplitude. The amplitude tells me how far we're going to stretch it down. We're going to stretch it down 3, so it's going to come down to -1. And then from number 2, I'm going to go up 3, which means I'm going to go up to 5. So my range for this is from -1 to 5. And if my flying hands in the air and my verbal description don't convince you, that's okay. You can sketch it, because you guys know how to sketch this graph. Just do enough of it that you can see to see the range. And this range is from -1 to 5. Okay? And this restriction for f, this is actually my domain too. Okay, so that's my restriction, it's the domain. Okay, I need to find this guy. I need to find its inverse. So these are the steps that you're talking about, or that I talked about right above here, finding the inverse. The first thing to do to find the inverse is to rewrite f of x as y. So this is y equals 3 sine 2x plus 2. Okay, so that's the first step. It doesn't really do anything except for have this little rewrite business. And the second step's similar. It's just a rewrite. I write x where y is, and I write y where x is. So far, so good? Okay. We can do those steps without really a lot of algebra really happening. Then the algebra comes into play, then the solving for y part. So when you solve for something, you want to get it isolated, you have to go from the outside and work your way in. What is the outermost issue going on the right-hand side of this graph? The plus 2. So that's where I'm going to start. The first thing I'm going to do is subtract 2 to the other side. So this will look like x minus 2 equals 3 sine of 2y. What is the next most outer thing that's affecting y? The 3, the amplitude 3. So I'm going to do what? Divide by 3. Subtracting will not help. Do not subtract 3. We're going to divide by 3. So I have x minus 2 on the left divided by 3 equals sine of 2y on the right. What is the next outermost thing affecting y? The sine, right? And what we want to do is we want to do inverse sine on both sides to get rid of it, right? That's the way we got rid of division, multiplication is we divided. The way we get rid of sine is we do inverse sine. And if you take the inverse sine of this, that's where the restriction information came in. That's why we need this restriction. I want to be able to eliminate sine and inverse sine with one another. The only way I'm allowed to do that is if it fell within the restriction range, just like we worked on in the previous problems, right? And because I've set the restriction range so that this will work, I can. I can eliminate sine and inverse sine on the right-hand side so that I do have simply 2y left. So it looks like that. I'm almost done. What do I have left? Divide by 2. And I want to make sure I divide everything by 2. Another way we could write that again would be to multiply by 1/2. And that works really nicely because then I can write it in front of sine instead of it sort of looking a little bit awkward. It doesn't look quite as friendly. So I can actually write this as 1/2 inverse sine of x minus 2 over 3 equals y. And that's the end of step 3. I solved for y. But step 4, again, is another rewriting step. You have 3 rewriting steps and 1 step that requires work. Step 3 requires work. Okay, the last rewriting step is to do what? Put what? Well, we will do that, but we're not going to do it with y. What was step 4?
Rewrite y as f of negative 1x.
Right. So it's a rewrite y. I will not have y in the problem anymore. I will have f of negative x equals, and I moved it to the left at the same time, TJ, 1/2 inverse sine of x minus 2 over 3. And here's why we found the range just a minute ago. We're supposed to find the domain in the directions it says find the domain of f inverse. We talked about last time. The domain of f inverse is the range of f, which means what is my domain of this function? -1 to 5. So if you don't remember to do it at the beginning, that's fine. You're going to do it at the end because it's part of the directions. The directions say to do 3 things. Find the restriction, find the inverse, and find the domain on the inverse. Yeah, I think those are the 3 features, right? Yes. All right, we've got one last problem in this section. And this problem number 9 is different directions. It's solving an equation. It's going to work very similarly to what we sort of looked at a minute ago on this last particular problem. So we've got 3 inverse cosine of 2x equals 2 pi. Okay, so the first thing that I want to do is I want to get that inverse cosine alone. Okay, I want to say inverse cosine of x equals whatever, or of inverse cosine equals whatever. What do I need to do? First thing, divide by 3. inverse cosine of 2x equals 2 pi over 3. And once I've done that, I can rewrite this in terms of cosine. Okay? So what I'm going to do literally is I'm going to put cosine on both sides. So I can't write it in here, but imagine there's a cosine in front of that on the right-hand side. Okay? Provided that there's not a restriction issue, and there isn't, okay, what we're doing is we're actually going to be able to do what here? Cancel. Those operations are inverses, which means I have 2x left on the left, and I have the cosine of 2 pi over 3 left on the right. And we're going to divide by the 2 in front of the 2x in a moment, but we don't really need to at the moment. First, I want to figure out what is cosine of 2 pi thirds. And that's a unit circle issue, right? Yeah. And 2 pi thirds is in quadrant 2, so this is all really good, right? And that's why I had a restriction that didn't matter, or I fit in with the restriction is because I'm in quadrant 2, so I'm okay to deal with this inverse cosine in quadrant 2. What is the cosine value of 2 pi over 3? It is -1/2. Okay, if you're shaky on your unit circle, go back and look at that. Have it sitting there with you as we're talking, whatever it takes. We need to be able to work with the unit circle. And then we're going to divide by 2 or multiply by the 1/2 to get rid of the 2 in front of the x. So x will equal what? -1/4. Is that right? Hey, we even did it in spite of all my technology messing up. That's pretty good, right?